Today's lesson is how does one solve radical equations? So starting with some basic rules before we get started, so we're best prepared as we can be. We need to understand going into this methods of factoring, extraneous solutions, and exponents. Starting with methods of factoring, one method that we use is 1am. With 1am, we're looking for a trinomial that is in standard form, meaning it's in y equals ax squared plus bx plus c form, and it has an a value of 1. With 1am, we're looking for two values that add up to equal the b value and multiply to equal the c value. An additional method of factoring that we need to be aware of is master product. Master product is similar to 1am in the sense they're both trinomials in standard form. However, they differ in the sense that master product does not require an a value of 1. Instead, with master product, you need to multiply the a and the c value, and then you wish to find two numbers that equal the b value, that add up to equal the b value, and multiply to equal the product of the a and the c value. Furthermore, extraneous solutions are also something that we need to be aware of with this topic. An extraneous solution is a solution that, when put back into the original equation, does not satisfy it. Therefore, with this topic in particular, we need to make sure that we re-plug in every x value that we get into the original equation to make sure it's actually a proper fit. Furthermore, with exponents, we need to bear in mind that you are not able to distribute an exponent. You cannot simply add an exponent to values inside of parentheses. That's not how it works. Therefore, we need to keep in mind that when we see an exponent, we need to make sure we FOIL it. So starting with our first example, our question is the square root of x minus 4 plus x equals 6. So the first thing we want to do is isolate the radical. So we want to subtract x from both sides, and you should get the square root of x minus 4 equals x minus 6. Then we wish to eliminate the radical. We can't simplify it any further if we leave it like that. So we wish to square both sides of the equation, and from that you should get x minus 4 equals 6 minus x squared. However, as we know, we need to FOIL this. So two sets of parentheses should open up, and it should be 6 minus x, and then an additional set of 6 minus x. From there, we need to distribute. So we should do 6 times 6, which would be 36, followed by 6 multiplied by negative x, which would be negative 6x. And then we need to repeat that for the second value in the parentheses. So negative x times 6 would be negative 6, and then again, negative x times negative x would be x squared. And then we want to bring down the x minus 4 from before. So our equation as of now should be x minus 4 equals 36 minus 6x minus 6x plus x squared. From there, we need to condense. We have like terms that can be combined. So once again, bringing down x minus 4 because that can't be simplified any further as of this moment. On the rightmost side of the equation, we have 36 minus 12x plus x squared. So now, because we have values where we have like terms on both sides, we can further simplify this. So from the left, we can add 4 to the 36, and we can subtract x from both sides as well. This should leave us with 0 equals x squared minus 13x plus 40. Now, as we've noticed from before, we have a trinomial that has 1 as a value. So in this instance, we should be able to use 1am. So we look at the b value, which is negative 13, and the c value, which is 40. Two numbers that multiply to 40 is negative 8 and negative 5, and those numbers also satisfy the second part, which is that they add up to equal negative 13. From there, we wish to open two sets of parentheses, both with x's in it, and we take the values that we got previously from, we take our negative 8x and our negative 5, and we plug those into parentheses. From there, we want to set x minus 8 and x minus 5, respectively, to 0, and we simplify from there. So we have two separate equations now. We have x minus 8 equals 0. We want to add 8 to both sides, which should give us x equals 8. And on the other side, we have x minus 5 equals 0, and we need to add 5. So we should have two x values as of this moment, x equals 8 and x equals 5. However, bear in mind, we need to check for extraneous solutions. So plugging these values back in, we see that 8 is rejected. 8 is rejected. When we simplify, we find that 10, we find that the equation is not equivalent on both sides, therefore it's not an actual solution. And so 8 is no longer a possible x value, but we find that the value of 5, x equals 5, is correct. Now we're going to look at a problem where a mistake was made. So looking at this, we can tell that like previously, the radical was already isolated. So they moved on to the next step. I moved on to the next step of eliminating the radical by squaring it, which had been completed. And then we see it FOILed, followed by the use of 1am and the simplification of those respective values. And we end up with x equals -7 and x equals 2. The mistake made here was the fact that I did not go any further. I failed to check my answers, and because of that, I didn't recognize that I had an extraneous solution. Not -7 and 2 were not legitimate answers. One of them wasn't correct. The correct thing would have been if we ensured that a check was there. So in this instance, we would have plugged in those x values that we got, -7 and 2, and we would have realized that -7 was not an answer. We didn't get the right, the work had been done correctly, but because of the lack of a check, which is necessary, we didn't realize that there was only one solution there, not two. Going further forward, you can prevent this mistake by remembering checks are not optional. They need to be done for this topic. They're critical to ensuring you have the right values. And even if you do all of the math correct up to this point, if you fail to include a check and you don't catch an extraneous solution, you will not be successful in solving. That's the end of this lesson. Thank you.